Hello and welcome to KeenOnMaths. This is my first upload here. We're going to be going through today past paper. So it's going to be a paper 1, so a non-calculator paper. And it is from May 2017. Now if you want to follow along by yourselves here, if you navigate to mathsgenie.com and then up at the top here there is GCSE papers, it's Edexcel exam papers. And then if you just scroll down to June 2017, paper 1, it's just this one here, and click on the title, and this is the paper I'll be working through. You might want to download that yourself, or you could print it out, or just do it on some paper alongside. So I am going to be splitting this into sections, so we'll do the first couple of pages. And I'll be explaining things in quite a lot of detail, maybe not as much detail as you need, so feel free to navigate through the video and skip bits that you don't necessarily need me to explain in full. So question 1 says work out the value of 2 to the power of 4. And with powers mean to multiply something by itself more than once. So this means 2 multiplied by 2 4 times. So 2 to the power of 4 equals 2 times 2 times 2 times 2. And then we can work it out. So let's do it a little bit at a time. So we've started off with 2, we've doubled it. So double 2 is 4. We're then doubling whatever our answer is. So we're doubling 4, which gets me 8. And then we're doubling that again. So altogether that's going to be 16. So 2 times 2 is 4, times that by 2 again, that's 8, times it by 2 again, that's 16. So 16 is my answer there. Now powers of 2, really important. It's the basis of binary, which is the language that computers use. So the powers of 2 actually come up in quite a lot of interesting places to do with technology. Question 2. Write 7.26451 correct to 3 decimal places. So this is a rounding question. Specifically, it's about decimal places. So there's different types of rounding. You could be rounding to whole numbers, to the nearest 10, 100,000 and so on. You could round to decimal places. You could round to significant figures. So they're all 4 different ways of rounding. But actually, the rounding you always do is always the same thing. It's always about seeing what's something that's close to this number but is simpler than it. Because if we've got lots of decimal places flying around, we don't have to deal with all the decimal places all at once, especially with the rational numbers. They carry on forever, so we're going to have to round them if we want to make them useful. So rounding is just about getting something that's close. So if we have a look at this, to 3 decimal places, that means I'm looking at the third number after the decimal point. So in our case, I've got 7.26451. My 2 is the first decimal place, my 6 is the second decimal place, and it is my 4 that's the third decimal place. That's the one I'm going to be rounding to. So if I just quickly do a number line here, I know that my number that I've got is somewhere in between 7.264 and 7.265. Those are the 2 numbers to 3 decimal places that my number's in between. And then we've just got to think, well, which one's it closer to? Is it closer to the lower end or closer to the higher end? Well, let's have a look. So it's 2645. So the number after it is a 5. Well, if I think about what's right in the middle of this number line, that is 7.2645. So up to this point, it's exactly in the middle. But then have a look, I've got a 1 on the end of it. So that pushes it ever so slightly, be so slight you can hardly even see it, just slightly above that halfway point. So that means I'm going to round it upwards. So it's bigger towards the end. So that means it's closer to 7.265. That's what it's closest to. Now, if it was exactly in the middle, so let's say it was exactly 7.2645, like this, which way would I round it then? Well, it's exactly in the middle. There's no real reason to choose going lower rather than going higher. But it's just mathematical convention that we say, well, in this one specific case where it's exactly in the middle, what we're going to do is we're going to round it up anyway, even though there's no real reason to. So if it is spot on in the middle, you just round it upwards. Okay, that is rounding. Moving on, we've got our first introduction of some algebra here. So we've got 7 times e times f times 8. And we can see we've got 3 different kinds of terms here. We've got 7, that's a number. We've also got 8, which is another number. And then we've got 2 different variables. We've got e and we've got f. And we're multiplying all these things together. So if I just pick out the numbers first and I treat them the same, well, if I just take, like if I rearrange this, for example, I could rearrange it like that. And I'm absolutely fine to do that because when they're all multiplications, because multiplication is commutative, because they're associative, I can move things around, which means I can put my 7 times 8 next to each other. And 7 times 8 is in my times tables, that is 56. So I've got 56 times e times f. Now in algebra, we don't write the times symbol. I suspect that's because it looks a little bit like an x and we don't want to get confused. So we get 56, instead of writing times, we just put the e next to it. And instead of writing times, we put the f just next to it. So we get 56 EF. And they're all multiplied together, which you can tell by the fact that there's no gaps in between them. They're next to each other, so they're all multiplied. Question 3b says solve, and this is a really important keyword that will come up again and again and again. If you've got an equation, and I can tell that this is an equation because it's got an equal sign in the middle, hence the equation, it's got an equal in it. If we want to solve an equation, we're trying to find out the value of the variable. And in this case, our variable is x, but it could be any letter, or it could even be a symbol. So we want to find out what is x worth in this situation here. And there's some really, really good skills used in solving equations. I think it's a really important topic that if you can nail that, actually, those skills you've used come up in so many different areas. So let's take it one step at a time. I'm just going to rewrite the question first. Lovely. And we've got to think, well, what have I done to my x to get it into this position? What have I done? Well, I've got x over 5 as a fraction. And over something, this sign in the middle, that is called the vinculum of a fraction. It means a horizontal line in maths. X over 5 means x divided by 5. So I could just as equally put x divided by 5 is 2.5. But just like I talked about with the multiply symbol, we tend not to use the divide symbol very much in algebra either. We'd rather use a fraction or a vinculum. So this means x divided by 5. So I've taken x, whatever that number is, don't know yet, and I've divided it by 5 and I've got an answer. My answer is 2.5. So I want to see, well, if I undo that, if I undo the process that I've just done, what would I actually get? So to undo a divide by 5, we need to do the opposite of dividing by 5. The opposite, also known as the inverse in maths, is going to be timesing by 5. So if you take any number, let's take 30, for example. If I divide that by 5, I get 6. If I then get my answer and times it by 5, I get back to 30. So dividing by 5, then timesing by 5, means my number doesn't change. It started at 30, it's back at 30. So that's what we mean by inverses. You can do one thing, then the inverse, and it doesn't change it. So in fact here, I've got x divided by 5, then times by 5. They're the inverses. So actually, I've just got x left over there because they've cancelled each other out. We call this process cancelling. Okay, and then I need to do 2.5 times 5. The reason I've got these arrows on both sides like that is because it's an equation. An equation, it has to be equal on both sides. That's what it means. It means equal. So if I times something by 5 on one side, I can't just leave it. That's changed it. So I've got to do the same on both sides, and then they'll still be equal. So I've got 2.5 times by 5. I'm just going to write that separately on the side here. I might just move it out of the way for now and then move it back up. So let's focus in on this, 2.5 times 5. There's a couple of different ways of thinking about this, but the one I'm going to use is going to help us practice some fraction skills as well. So if I've got 2.5, that is what we call a mixed number, because we've got a mix of integers, whole numbers, and fractions. So if I want to do anything with these, if I want to use them in operations, you're going to want to, most of the time, change it to an improper fraction first. So that's when I don't have an integer part, it's just all a fraction, even though the top is, so the numerator is greater than the bottom, the denominator. So 2.5, I'm going to just separate this out once again and come back to that in a second. So 2.5, I want that, and I want to see how many halves there are in 2.5 altogether. Well, how many halves are there in 2 wholes? Well, let's do some diagrams representing 2 wholes. That's my 2 wholes. There's one whole, that's another whole. And then I'm going to split them into halves. So if I split that into a half and that into a half, then how many halves have I got all together in my 2 wholes? Well, I've got 1. It's a little bit big. Let me resize that a little bit smaller. So that's 1 there, 2, 3, 4. So in my 2 wholes, I've got 4 halves. And then I actually also have an extra half here. So I've got 4 halves in my 2 wholes, then I've got 1 half extra. So I'm going to just add that in. So that is 1 extra half. I'll just get rid of that little extra bit I've done there. And I've got that one as well. So altogether I've got 1, 2, 3, 4, 5 halves. So there's 5 halves in total in 2.5. Now there is a shortcut method for this. However, I think using these bar models helps you really understand why it's the case. So for speed, it's good to learn that, well, in 2 wholes, if I just times that by the denominator, I find out how many halves are in it. 2 times 2 is 4, so there's 4 halves here. Then I'm just adding on this 1 half on top of it. So you times by the denominators, then you add the numerator and put it over the original denominator. Now for me, I like to understand what's going on and why. But if you just want to learn that method, it will work, but I think understanding it is so much deeper, so much richer. So I'd recommend thinking about it in terms of, well, how many halves is this actually? So we have now got 5 halves, and we are going to be multiplying that by 5. So I've got a whole number times by a fraction. Well, fraction times by fractions are nice and easy. So if I can change this whole number, a whole 5, into fractions, then it'll be nice and simple. So my fraction 5 is actually 5 over 1. Now that seems a little bit weird putting it as a fraction like that, and that's because we don't usually write it. But any whole number is that number over 1. So this kind of means 5 ones, roughly. So we've got 5 ones and we've got 5 halves. And now we're going to multiply together. Well, to multiply fractions, it's as simple as multiply the numerators. 5 times 5 gets me 25. And 2 times 1, that will get me 2. So I've got 25 over 2. Okay, now we've got our answers. I'll take this working out and I will shift it here. Oops. Kind of want it a little bit smaller as well. There we go. So it's just not going to get in our way. And that means that we've got our answer for this. It was 25/2. So x equals 25/2. That is my final answer. 25/2. And if you want to change this to a decimal, you do not have to. And improper fractions, it was perfectly fine. And in the question, it just says solve it. Well, we've solved it. But as a decimal, half of 25 gets me 12.5. And as a mixed number, it's 12.5. All these three things are equivalent to each other, so any answer is fine. So we're absolutely fine just to leave it as 25/2. That's no problem. Okay, I spent quite a while on that because there's so many good skills in there and there's a lot you can go into even though it's only a 1-mark question. So in reality, it won't take you very long in an exam. You should be aiming for around 1 minute. However, there's quite a lot of detail we could go into if we wanted to. Question 4, the final question of the first page, that all-important first page. Write 4/5 as a percentage. Hello, sorry about that. My pencil cut out, so I couldn't write on the screen anymore. So I've just refreshed it and it seems to be back up and running. We're on question 4, write 4/5 as a percentage. And I was just about to say, I really like my Latin roots of words. So if we have a look at the word percent, per here, this means out of, and cent is Latin root meaning 100. And you can think of that in terms of dollars. So dollars are split into 100 cents. Years are split into centuries. A century is 100 years. What's another example? Roman centurions were in charge of 100 soldiers. So a century was 100 soldiers. And I think that's probably all the examples I've come up with off the top of my head. So this means out of 100 literally. So if I'm trying to write it out of as a percentage, I'm writing it out of 100. So I want 4/5 out of 100. So instead of being out of 5, I want it out of 100. Well, how do I get from 5 to 100? Well, I know how to get from 5 to 10. That's times in by 2. So from 5 to 100, I need to times it by 2, then times it by 10. Or times it by 20. 5 times 20 gets me 100. And I need to do the same on the top. 4 times 20. Well, 4 times 2 is 8. So 4 times 20 is 80. I've got 80 out of 100. And since percent just means out of 100, this is 80%. Nice and easy. Now, another alternative way to do this, which is sometimes useful, is to see this fraction as a division. So 4/5, as we talked about with that vinculum, it means 4 divided by 5. And if I did that, so 4 divided by 5, 5s into 4 goes 0 times. And we've actually not used anything there. So I'm going to carry all 4 across. But I've run out of numbers. If I run out of numbers, I need to put a 0.0 because 4.0 just the same as 4. And I'm going to have to add a point up here as well. 5s into 40, well, that goes 8 times. So I get 0.8 here. And you may be able to see the connection between the decimal 0.8 and the percentage 80%, because 0.8 is a decimal, and to change that to percentage, all you need to do is kind of undo that percent, that divide by 100. So to undo that, I times by 100 and I get 80. And that is the 80%. So we could see it as decimals, but I think the easier one with this is see it as fractions. It's also a really good one to know your fifths. So 1/5 is 20%, 2/5 is 40, 3/5 is 60, 4/5 is 80, and 5/5 is 100% or 1 whole. And of course 0/5 is 0%. So they're good ones to memorise. So since this is a 1 mark, if we'd memorise that, that would be as simple as writing it down.